we enlighten ourselves in several areas, either it being our career or what we need to do at our workplace. So we're having another section today, and we also have monthly section where we have that once in a month. So like I mentioned earlier, I'm super excited, yeah, because this month is a very important month to us. But before that, if you would love to be part, that's for those joining us for the first time. If you love to be part of our community, in course of the meeting, I'll be dropping links to our several channels. So please do where to join us and stay connected. So tonight, I'll be moving straight into welcoming the speaker of tonight's section. He's not the person, the engineer, Ericsson Raphael, staff at Morning Point. Please, could you react with your favorite emoji? So Raphael will be walking us through an important topic tonight. I believe those on our platform are already aware, but those that are just joining, he'll be talking to us about designing tenant systems as skills with Spring Boot. Like we've been doing Spring Boot back to back, yeah, this particular year. So we are still in the season of Spring Boot. So Raphael will be walking us through that topic tonight. Without wasting much of our time, I'll be welcoming Raphael to have the floor. I'm not seeing anyone reacting to that. Okay, let me also send out my reaction. Thank you, Rosemary. Thank you, Auni. Yeah. Raphael, you can have the floor.
All right. Good evening, everyone. Can anyone hear me?
Yeah, I can hear you, but I would like you to turn on your camera for the introductory parts.
I'm not looking for that part soon. I can't turn on my camera right now. Maybe eventually.
All right.
All right. So diving right in, I'll be talking about design. Okay, first off, my name is Ericsson, Raphael. Right. And I'll be talking about designing multi-tenant systems at scale with Spring Boot. So I'm sure we've probably come across the term multi-tenancy in software engineering. And even if we've not, think of it as a case where you're trying to just like this animation entails, as opposed to a case where you're serving a very direct customer base, B2C type, right? In this case, it's like a SaaS, it's built on, you have SaaS platform like mechanisms where you're serving different businesses. For example, say your company needs a workspace for chatting, right? You won't probably go, it's now a whole enterprise looking for a chatting application. Now, as opposed to them probably building their own chatting system, you have different platforms like Google Chats, Slack, that provision these tools that enables businesses to communicate in an isolated manner. Isolated being that one business does not see the business of another, or one enterprise does not see the business of another enterprise. And they handle this efficiently. So in essence, again, I'll just be walking us through the logic or the thinking that goes behind, or how these systems are designed to handle the capacity that they deal with. Because as opposed to a case where you're just dealing with one company, which can probably have hundreds, if not thousands of users, you now have hundreds or thousands of different businesses that, I mean, if you do the mathematics, you get what I mean. So in this presentation, we'll be discussing what multi-tenancy really is, the types of multi-tenancies, the multi-tenancy systems, or how they are portrayed usually. Then we'll also discuss or dive into the more technical side, starting from the tenant's identity and the context propagation, essentially how we handle retaining or passing a particular business ID or context rather, without mixing it up with other enterprises. Then also we get into the Spring Boot side of things, how we implement it using Spring Boot. And then finally we'll round up with the more intense system design strategies or scaling patterns that we can introduce or we introduce into a system like this. So first off, I mean, okay, just to clarify, a tenant is not exactly a user. Like I pointed out earlier on, as opposed to a case where you have just one user or multiple users or thousands of users, a tenant is essentially a business, or it could be a business rather, right? It could be a business that has many users, or a company that has many users, as opposed to just having direct users. For example, Instagram is not necessarily, it's not a SaaS platform. They don't have multi-tenancy integrated in it at the high level. First, you can say something like group chats is kind of a way of integrating multi-tenancy, but it's not a multi-tenant system, right? So yeah. So very good analogy for you to better understand the idea of multi-tenancy is, first off, when you talk of, for instance, let's say you have an estate and you have multiple houses, each person owning their own house. Now, for their user, they can choose to do whatever they want to do in their garden. How they choose to paint the house is their business. The furnitures in the house is, please, can any other person see what I'm presenting? All right.
We cannot see.
Okay. Okay. So as I was saying, the level of isolation that a person that owns a house has in terms of what they choose to do with their house and everything that happens in their house is entirely different from a case where you have an apartment block and you have multiple people sharing, multiple people having their own different apartment blocks. If there was a case where there's something wrong with the foundation of one building, everybody in that apartment will go down, as opposed to a case where you have different buildings with their own foundations, their own operating rules and whatever. Now, another level, right, of abstraction is now a case of, say, a hotel or even a hostel, right? You have different bed spaces, but for a singular room, right? So everything that happens in that room affects the individual users of that said room. So essentially, this is the different level of abstractions, right? For detached house, think of it as you or a business having their own DB. It could be for the same application layer, that is the same code that runs for everybody, but they have their own DB layer abstracted from the rest of the people or from the users. Now, typically for this kind of level of abstraction, it's not probably the best. I'll get into that eventually, but all you need to know is that it's the most isolated form or type of multi-tenancy implementation. Then for the apartment block, you could it's more like the shared schema kind of thing, where you have, or rather shared DB but separate schema kind of implementation, where you have each user having their own different schema in the same database, right? Then for hotel, you have a shared I say shared database rather, different schemas for a shared server. But for the hotel side of things, it's a case where you now have everything put together in one DB. And the only way you can isolate a business's data from the other is by row or by the tenant ID column. Now, noisy neighbors and blast radius are plumbing problems. What does noisy neighbor mean? A case where one user, and these are problems for, say, the apartment block illustration of hotels. Case where one user is using too much CPU, right? Or there is something, there are lots of API requests for one business in a multi-tenant system, right? For whatever reason, it could affect the rest of the users if they're sharing the same DB, right? You see that their requests are slow for some reason or whatever the case may be. As for blast radius, if there is any attack on your DB, it's affecting every single person in that same database, as opposed to that level of isolation where you have separate databases. But yeah. So, what's single tenant? What's multi-tenant? Single tenant is a case where you have a separate application layer, separate everything hosted differently, right? Now, for single tenants, the advantage is that you have the benefits of flexibility to how you want to change your application, right? Any major change that goes on at the application layer, right? Any major updates affects every other person for multi-tenant systems. But for single tenants, it's that you have your own application, you have your own DB, essentially like a company saying, oh, I want to build a chatting system for us. That's a single tenant system. Everything serves you and you alone. But for multi-tenant systems, right, you now have, and I mean, a company can, or a business, or multi-tenant system can choose to host application layers and DB separately for different companies. They can provision that service, right? So it's not about them doing it themselves. But for multi-tenant systems, again, it's all about you sharing everything across, depending on the costs or whatever, depending on the costs, the infra bill or whatever analysis you've done on your part. I don't know if someone is raising their hands, or we'll get to that. Now, why do SaaS companies do it anyway? First off, it's cost effective, right? Most often than not, you have multiple containers running. If it's in the case of single tenant systems, you have multiple containers, multiple systems running for companies that might not even use it so much. So as opposed to you having different systems for each user or each tenant rather, you could allow them to share that at least application layer and yes, manage it properly from that point. Another problem is the fact that having to manage this infrastructure is usually very tedious for the infra guys. So imagine having to manage one system alone, and then you now have to do that separately for each and every one of the tenants you have, right? So it's not exactly the best way to go about it, depending on the use case, right, or the demand. Then also having to onboard a tenant is very complex and very tiring. Anyways, so what do you pay for? I've talked about what maintainable is, and I've talked about shared blast radius. Now, in the case of a data leakage, any bleed or any data leakage from one DB affects everybody under that same DB, right? And yes, there's a lot of attention that needs to be paid to every single layer of the system, from the caching layer to how metrics are dealt with, the logging mechanism, and so on and so forth. Again, we'll dive deeper into that side of multi-tenancy later in the presentation. Now, these are some examples of companies that implement multi-tenancy. or make use of the multi-tenancy systems. I've talked about, say, Google Chats or Google Workspace already, but these are some other examples. Most of us have probably used Shopify, where you can have your own e-commerce platform or web app, right? You can modify it as you like. You can put your name and whatnot. You can host your products or sell your products, and it's not affecting any other business owner on that same platform. Another example for most of us that we're conversant with is Slack, right? Whatever thing going on for your company is not affecting that of other people, right? So different tenants or companies or enterprises on board and make use of their of Slack, right, separately. Now there's another side to multi-tenancy, which is white labeling, but that's just you basically using all the system but tagging your name on top of it. So instead of using Slack there, for a certain amount of money, you want to be your own company's name, but that's by the side. Sorry, that's besides the point. So this is an animation to probably understand how the whole how multi-tenancy solves the whole issue of having to handle different infrastructures or containers deployments, right? So you have one version handling the application layer, you have one migration across the stack, and so on. Now, these are the SaaS terminologies, software as a service. These are the SaaS terminologies for the three different types of, or the three different main types of multi-tenancy, right? Silo is the more abstract, more isolated layer where you have a database per tenant or per enterprise or per whatever you want to call it, right? Now the bridge is the midpoint where you're trying to bridge between the cost of having to host different databases per tenant, right? If you have about 1,000 tenants, you're hosting about 1,000 databases, right? That's an increase in cost. The bridge is the midpoint where you're trying to solve that, but then you now have the cons of not so much of your data isolation that comes with, say, pool. Now, pool is the most cheapest, right? But then again, there is zero isolation. Everything is in one database or table, and the only way you can differentiate one tenant's data from the other is by the tenant's ID column, meaning that for every query you run, you are passing the tenant's ID, where tenant's ID, and whenever you don't do that, it's going to be catastrophic, right? Now, typically, Silo is usually reserved for premium clients, right? And I mentioned I was going to get into this eventually. So most often than not, the companies or the industry that makes use of Silo are one government systems, right? Because of how confidential their data is. Another example is healthcare systems or even defense systems, right? They can't afford to have a case where there is any issue about data bleeding into another person, or one person causing an issue on one, like noisy neighbors or blast radius cases affecting them. So they would rather pay for that. But for bridge and pool, bridge is usually reserved for people that are willing to pay more for more abstraction, right? As opposed to pool, depending on their user capacity, right? So it's usually like a tiered payments kind of implementation. Now, these are the trade-offs or the decision matrix you consider when you want to go with either of the models. In terms of isolation, Silo is the strongest. Bridge is the midpoint, and pool is entirely up to the orchestrators to ensure that it's isolated well enough, but then it's not as secured as the rest. I've talked about costs. I've talked about the migrations and so on. So what everyone converges on, pull by default, right? So say on Salesforce now, let's say I want to start a company and I go on Slack or Salesforce or whatever. Usually you probably see different payment plans, right? And maybe if I do not have a particular user capacity, I can go with the cheapest one. And maybe that cheapest one would provision a silo case. Again, these are just SaaS terminologies. It's not that, oh, this is what we call it, right? I think it was adapted by AWS or so, but usually, so when your user base now grows to a point where you demand more capacity, you demand more isolation, then you transition to, or you can be upgraded to a better payment plan, which is like the pool system. Now, okay, I think we've highlighted this already. Now, okay, now we're getting into the more technical side of multi-tenancy. Starting with, now, how does the application layer, right, know what tenant it is provisioning? I shouldn't log into Slack and then I'm seeing data from another company, or I'm seeing chat messages from another company. So how does the application layer know that, okay, this is what we should serve this person, this is what we should show this user, right? Starting with, we have the subdomains, right? This is just basically, we all know like what domains are. Domains are basically the endpoints or URLs. That's the general way to explain it, right? So Acme is an example. We're using that as an example of our company now. So you could have acme.app.com, you could have another company.app.com. It picks that up and then it uses that to route what data to serve you. Now, okay, maybe I should just continue explaining, right? We have path prefix. This one is not usually implemented, right? Because it's just you adding more prefix to the path, right? At the end, you're adding more slash, whatever. So it could eventually pollute the route, right? Because for instance, you're trying to go to the login of a particular or dashboard of a particular user, you're having acme/this/that. That could eventually pollute everything. The JWT claim is where you sign the tenant ID that comes into the application layer. What does this mean? Basically, you encrypt and sign it to track truly that this is coming from the right source. Let me give a better example. I could be someone that wants to actually get into another company's system and have access to their, say again, since we'll be using chatting, you want to see their charts, you want to see the data. I could just change the ID of the tenants and get access to their data. So how would the application layer know that, okay, this is coming from a verified source? It's by signing it. And that's what JWT does. Now, the X-tenant header is basically how we pass it's another way we pass the tenant ID through the header of the request, right? And API key is another option. Now, when or where do we use all of this, or do we even use some of them? So usually we go with a hybrid approach, or it depends on what is supposed to make use of it. Subdomains it could be a general thing, right? Well, most often than not, it's for public or unauthenticated or unauthorized pages. For instance, maybe the sign up page or that login page, right? You could use that as a way to route your tenants, right? But for more authenticated pages where you want to probably access your dashboard, right? You can't use that because that can be easily changed. Same with your X-tenant ID header. Anybody can just go to the header and change anything to just access whatever, So typically you go with the JWT claim. As you're encrypting the after login, as you're encrypting the user ID, their role and whatnot, you also include the tenant ID in it. Now, that is not to say the rest of the other options are useless. You could go with the headers when you have like a microservices system where one service can communicate to another service. But then there must be a layer that would definitely affirm that, okay, this service is a trusted service for you to just pass it through the header just like that, right? Because you wouldn't want to log the user out if you're using the JWT just because you're trying to cross transfer data or this request across services. Then, so yeah, now how do you, now this is at the Spring Boot layer, how do you ensure that the tenant ID is followed through or is passed for every request at the implementation layer? You use, or this is where we do the whole coding jargons, right? This is a tenant context. Now, what does this do? So this is done at the filter level. Now we're getting into terminologies like thread local and thread pool and whatnot. But what all of that does, or what all of that is, basically is, for the older parts of Java, it's built on the concept that you have reusable threads for concurrent requests in a pool. That's essentially what thread pool is. Now, thread local is all of this implementation where you're trying to attach the context of the tenants to a particular thread, ensuring that from the birth of that request to its death, that tenant ID is used. That way you can now filter your database requests by tenant ID. Now, at the end of every tenant context, or at the end of every thread local, you're supposed to kill the finally block, right? You're supposed to kill that thread and kill that tenant ID. If not, it will be propagated to the next thread. Again, like I said, thread pool is all about reusability of threads or recyclability of threads, right? So once that thread is recycled, another user can now have access to another company's data, and we don't want that. So we have to kill it at the end of every request cycle. Now for Java 21 Plus, we use a different approach because that's when you're talking of virtual threads, right? So for virtual threads, you're not using OS level threads anymore. And for that, you use scooped values. More on that later. So at what point or what instances can we have cases where the context is leaking? What do I mean? For instance, now, for an async operation, you have a background thread picking up tasks. So how do you ensure that it retains the context, right? Because for asynchronous operations, you don't have the context being passed automatically. So for that, you have to add this executor service to ensure that it extracts the tenant context from that thread onto the background thread. Same is kind of applied to reactive or web floats. This is for reactive programming, right? Where you're hopping between threads. You also have to transfer the context, right? For Kafka and messaging queues, you have to attach the context, the tenant ID to every event, right? To ensure that your tracking is properly. Same with scheduled jobs. You need to, for every job that you want to create or run, you have to ensure that the tenant ID is attached to that. I mentioned scope value for virtual threads, and this is its implementation. Essentially, again, it's just basically automatically handling the whole tenant context. So instead of having to even define the final block at the end of your request, it will automatically kill it for you. All you just have to do is to ensure that you are integrating it at that filter level. Okay. So yes, this is how you. So how does how does or how do databases now pick up on the tenant's ID? How do we ensure that they are communicated to the tenant's ID? To the database, the tenant's ID from the service layer or your implementation layer. So we usually make use of this decorator, this tenant's ID decorator at the entity level. Now, what would this do? Hibernate being the Java's ORM, would automatically ensure that for every of your query, right, that the where tenant ID equals to this would be attached to it automatically. So you do not have to hard code or hard write that code into your repository method or whatever or query. Now, the problem with this, right, is that you have cases where for raw SQL queries, Hibernate will not attach that for you, right? And you now have cases where maybe the developer forgets to now hard write or hard code the where tenant ID equals to whatever tenant that is. So what other level of security can we implement or integrate to ensure that no matter what happens, that abstraction is still in place, where you don't have, or that security is still in place where you don't have one user, one tenant having access to another tenant's data. And that's where the role level security come into place. Now, what does this do? Basically, you have to create the policy, the tenant policy for the role level. So, sorry, the tenants, right, after the Hibernate has handled whatever, right, and you don't have, hold on. For role level security, it automatically ensures, that if the tenant ID is not passed for that particular query, right, it will automatically attach it for you. Now, how does this work? The tenant context, right, is picked and integrated through this policy that has been created. So this case where you see this app.tenant, right, it would pick the tenant ID from that tenant context, right, at the application layer, and then it would integrate it for you. So that way, even if you forget to add your tenant ID clause or where clause, right, it will automatically return only the data that pertains to you at the database level. So again, the difference between this and the one we talked about earlier on is the fact that this is done at the database, the DB level, right, as opposed to the other one that Hibernate happens to manage for you. Now, how do you route the request or retrieve the data for the different kinds of multi-tenancy systems, right? We talked about the silo model, that's like database per tenant and so on and so forth. So how are all of this routed? Now, Hibernate handles this at the schema level. Hibernate would again propagate, it will pick up the tenant context and handle everything for you. For the schema level, for the role level, that's not a problem, right? Now, but for the database level, there's usually another layer that you have to integrate, right? So you have like a map of all the tenants and their IDs and whatnot, and then it picks from there and then routes to that particular database, right? So that layer is what differentiates how the rest of the other kinds of what did you call it? Multi-tenant systems are dealt with. That layer just ensures that you pick the data ID and then you route to that particular DB that data ID is keyed to. Okay, now this is more of the scaling side of it. And this is when we're talking about the connection pool. So to better explain this mass, right? Say for instance, for a particular application layer, you have a million requests, let me not say a million, 1,000 requests. Now, the max that say a DB could probably handle, let's say it can probably handle max of 30, for instance. Now, how do you reduce the number of connections enough for the DB to be able to handle? Now, that's what Hikari CP does at the application layer. So it basically compacts those connections into a pool, right, where they can be recycled and picked up after one. So if one request is coming in and there are no available, what do I call it now? Connections for it to pick up. It basically waits till another one is done and then it picks it up. Now, it could be done per transaction, it could be done per query. Typically, it's usually done per transaction. So it will basically wait for a transaction to be done before it releases that connection, and then another connection will pick it. But that's at the application layer. Now, the thing about multi-tenancy is that's say you have 1,000 requests for one tenant. But now let's say you have 1,000 tenants, and each of them are coming in with 1,000 requests or connection requests. And you could even probably have 3 different application layers or instances being hosted at the same time, right, for uptime. By the time you do all the multiplications, your DB would fail. It won't be able to handle that load. So that's where another layer comes into play, and that's PG Bouncer. Now, what does PG Bouncer do? Basically does what Hikari CP does, but now at the DB layer, right? So it sits in front of your application, and it sits in between your application and your DB, and ensures that it reduces all those many connections and trims it down to what your DB can handle. Okay. Now, how do you deal with migrations when it comes to multi-tenant systems? The go-to is Flyway. And for the pool system, right, that would work very, very well. That would work just fine, right? And I mean, it's not like there's even an alternative to that for the other systems. The only thing you just have to take into account when it comes to multi-tenant systems is that you need to ensure that your migration is backward compatible. That's basically what this expand contract mechanism is all about. So what's the expand contract all about? Is this 5 different layers, this add dual rights. Let me take it one by one. Say you want to make a change or change your column, a particular column, from say name to names or whatever you want to call it. If you just go and make a change to that listing and just migrate that, a lot of things could go wrong. Starting with, for a particular schema, when we're talking about a breach, for a particular schema, you could have a case where an error happens. So because of the error of the 400th tenants, the rest of the tenants won't now get their migration, or everything will now fail, right? Or you could also have a case where just a couple of things that would affect everybody at the same time. Now, what this backward compatibility means is that you can revert, right? Or you can have a couple of live hostings all at the same time as you're making your changes. So at the additional level, you're creating that other column, the names column. Now, at the dual rights level, you're writing to both columns. You're still writing to that name that you're trying to remove, and you're still writing to the names column that you've just added. Now, at the backfill level, you are now transferring, maybe with a job or whatever, you are transferring all the historical data and that name column to your names column in the background while you're still writing to it. An alternative to dual write could just be that you could make a read-only, but that's not, it's better to just go with the dual write. Now, for the switch reads, that's where you now switch the attention to the new column that you have added, right? So no other this thing is now writing to the column. Everything is focused on the new column you've created, right? And then you can drop the former column. All of this now at the migration level is done in such a way that the applications talking to the old application or the application talking to the old schema is still live while you're still making the ones talking to the other. Oh, that's another layer entirely. But this is basically how you handle migrations across many different types of multi-tenant systems. Now, for the caching layer, it's very straightforward. You're basically just attaching the tenant ID to every key that you make. Let me see if something is on the next slide. Okay, it's not. But what you're basically doing is you're creating a decorator, or you're implementing a text, I think it's the key generator. At the key generator level, you're implementing that, and then you are fine-tuning a decorator, or even at the config level of the caching config. You're making a configuration that basically adds the tenant ID, cutting from the tenant's context, to the key that is being generated. Now, if you do it at that config level, it's advisable because you just still attach your as cacheable, and you just know that that tenant ID is still added there. The alternative is doing it at the point of creating that cache, but then you have cases where developers will forget to add the tenant ID, and that can be catastrophic. So essentially, it's just you doing it at the config level where you have better control over how everything is happening. And a case where you have the tenant's ID not being there, it's not as simple as just a breach. It's a problem, because then you have data bleed, or one data having access to what it shouldn't. Now, at the testing layer, just like how you handle testing generally, you're testing not just for the happy parts, but also for the sad parts where you are accessing from one tenant. Tenant A is trying to access tenant B's data. That should not work. That should not be the case. Now, Arc Unit is another tool that you could use. Now, what does Arc Unit do? It basically checks the repository layer, all your queries, and it ensures that all your queries are adding is it the where clause, or at least, like I talked about earlier on, that's at tenant ID that Hibernate handles, right, for cases that are not raw SQL queries. So Arc Unit would basically run that check to ensure that this is done across the repository layer, so you don't have a case when it's on prod that everything is now is messed up or whatever. Okay, so how do you deal with the noisy neighbor case? To reiterate again, noisy neighbor is a case where the consumption of the resource consumption of one tenant is affecting the rest of the tenants. What does that mean? I mean, I've highlighted it before, but what does that mean? It could be that one tenant is having one field request over and over again to a third party, maybe a third party system or API, or it could be that there's a spike in the numbers of requests that it's receiving for that same tenant. So how do we handle this? First off, they go to rate limiting using bucket 4J and Redis as its what do we call it now? Is it DB or what? But what does this? You just basically again ensure that you are attaching the tenant's ID and you're rate limiting by tenants, right? However algorithm you choose to go with, you just ensure that each tenant is tied to the rate limit. Each tenant's ID is tied to the rate limiting logic that you implement. For bulkhead patterns using resilience 4J, bulkheads basically ensure that catastrophe on one thread doesn't propagate to the rest of the threads. It doesn't affect the rest of the users. So you're restricting that error to just that tenant. So whatever is slowing down, maybe it's a repeated request to an external a third-party API, right? You could also integrate circuit breakers, right, to kill off that request and retry later. But then the bulkheads will just ensure that the problem of one tenant is not affecting the rest of the tenants. I hope I've not lost track of time. Okay. For query guards, it's basically the same thing, right? I'll try and speed things up. But you ensure that you have a timeout for every of your queries. You don't have a long-running query. You should have a timeout for it. You enforce pagination, the maximum number of rows you want to retrieve per request, right? Then you also have, for your queuing mechanism, you just implement an algorithm that, it could be a weighted algorithm to just ensure that the asynchronicity, or a case where a tenant is having how many requests, you won't now say the rest of the tenants won't have access to pools just because of that. So you limit it, right? Or you have an algorithm that will ensure that, everybody gets a fair share of the resource. Sharding and cells. Sharding at the DB level is just you ensuring that. Now, okay, let me talk about the problem that could come with this. For the DB layer, you want to abstract, or you want to ensure that you do not cap the DB constraints because you're vertically scaling, right? You could scale and reach the cap of that PG, and there is nothing to do. So what do? You could shard, and your sharding key will be the tenant's ID. What does this mean? You could have tenants 1 to 10 or 100 on one DB cluster, or one DB server, or one DB node. And then you have another set on another cell, or whatever you want to call it, right? So that's to just ensure that you do not hit or you do not stress your DB, or you do not max out the capacity of that DB. Okay. Your indexing. We talk about indexing a lot. Everybody knows about indexing. But for all your indexing, it's going to be a composite. It has to be a composite index where you are indexing also the tenant's ID alongside whatever you're trying to index, right? Because you want to, again, make sure that you are isolating the data to who it concerns, right? I've talked about sharding or partitioning, DB partitioning. Okay. For observability and tenant dimension. Okay. At the layer where you receive your requests at the filter level, right, and you're trying to attach the tenant's ID to the tenant's context, there is usually something you do, and that is to using, I think it's called SLFT. It's a simple login facade for Java. SLF for J. So you're essentially, it's just a login mechanism, right, for better tracing. So you want to be able to tell that, okay, if something happens, if a tenant is reporting an issue, your go-to is the logs. You want to go, but you don't now know whose request or whatever you want to trace. The tenant's ID being attached to every log is the proper solution, right? Now, for micrometer tags, you cannot, there's a risk with having to append the tenant's ID for every micrometer metric or tag, right? I'm trying to remember, I think it's called cardinality. So you do not want to reach a high cardinality. Now, the way it works is that micrometer use this kind of, is it set stream or something like that, where it's basically picking all the tags. And if you have a case now that you have a 10,000 tenant system, it will be too much for you to process. If you have, say a tag for 200 for the status code. You want to pick all the status codes. You want to aggregate the status codes, right? Fine. That would work. That would be fine. You can get your hundreds or whatever. But when you're not trying to pick that and pick that for the many tenants, depending on the scale, you could reach high cardinality, and that would affect your micrometer system. So what do? You could reserve the micrometer metric for maybe a certain level of your tenant base, maybe the ones that will pay higher, or for a secluded few, but not for every single one of them, right? Then also you integrate your per tenant health view for you to properly monitor the health metric of each one of your tenants. For this, your control plane, as opposed to your control plane versus your, what do you call this other plane? Your control plane essentially is just the admin level for whoever is operating or orchestrating that particular platform, right? So it's just like how you have your super admins, your admins, their view, as opposed to every other user. That is what the control plane is supposed to be for. So what is this saying? It's simply saying that you have to properly monitor, you use that, you have to implement it properly, because most people are usually very lackadaisical with how they build the control plane, right? But for proper per tenant monitoring, or per tenant future flag, or having to, configure one thing or the other across tenants, your control plane has to be intact. If I remember the other plane, right? I think that's the, anyways. So yeah, canary for your deployment and to avoid a blast radius kind of system. Canary is just basically you deploying to a select few tenants before you deploy to the rest of the tenants, right? That's what's canary for users. But in the case of multi-tenants, you want to deploy to a particular number of tenants. You want to roll out a particular number of tenants before you roll out to the rest, so that you do not have how many tenants experiencing failures across board, rather, right? So you roll it gradually. You can first roll out to people that are making the free payments. You monitor the health metric, you monitor everything. If it's going well, then you gradually roll out to every other level of your tenants, right? You also have I think it's called the blue-green deployment process, where you ensure that after deploying the application layer or whatever, you monitor the health metric and whatever. And once it's live and everything is good, then you can now convert all the distant requests to the newly deployed layer. So yes, you roll out gradually, as opposed to just converting everybody to a newly deployed thing, to avoid a large or a complete outage. So yes, this is basically the summary of all the issues that you could encounter in a multi-tenant system, right? You could cache your keys and forget to attach the tenant ID, be it at the config level, at the level where you're creating that particular cache pair. So you must avoid that. Also, you must ensure that your thread local is cleared in that final block to avoid it being recycled, and then the next user is picking up the request and getting access to the last tenant's ID, right? Also, you must trust, if you choose to go with strictly going with the client supply tenant ID, that's the X header ID, attaching it to the header, you must be sure that you trust your client. And typically, it's not best to go with this, except it's one service talking to another service. It's better to just go with signing it with your JWT. Also, ensure that you're going with your composite index so that your tenant ID is also indexed for quick queries. Your connection pool should be per tenant, right? Also, that's even true. There's also another data privacy, is it law I will call it, that you have to take note of. So at the end of every contract, you must ensure that you are deleting the data that pertains to a particular tenant. You cannot store it in your DB for whatever reason, right? So if one company chooses to migrate from Slack to an alternative, Slack cannot keep all of that in your DB, in their DB, right? For whatever reason. Now, also, you must monitor the noisy neighbors in your system so that you can properly handle a case where it's cascading from one tenant to the other. So yes, there are three things for you to take out from this whole presentation. Isolation is a spectrum. There is no perfect go-to. Most often than not, multi-tenant systems implement a hybrid approach, right? Like I highlighted earlier on, where maybe free customers or free tenants would have access to the pool as opposed to the silo or bridge rather. Then the tenant context is also an infrastructure, not a utility class. It's not something to be joked with. And it must be enforced in every layer possible, from the application layer to the DB layer. So yeah, that'll be all from me. I'll be taking questions and
Thank you so much, Raphael. Yeah, thank you so much. All right, but before I welcome the questioning and answering section, I want to apologize for exceeding our actual time. And I also want to recognize the Java Group admins that are on the call. So for tonight's section, we are privileged to have Mr. Jonathan, is one of the Java Group admin, Ebube as well. He's also one of the Java Group admin, and Mr. Amos and Miss Rosemary. Thank you so much for joining us tonight. So, Mr. Jonathan, you can go ahead and unmute and ask your question. Thank you.
Yeah, thank you, Gloria. Thank you, Ericsson, for the wonderful session. So I want to ask a question regarding the DB design for a multi-tenant system. I think I heard where you said the tenants shouldn't share the same database. Can you clarify about that? Thank you.
okay, I didn't say the tenants should not share the same database, right? Like I said in this particular slide, isolation is a spectrum chosen per resource. Depends on your demand or your resource. Sharing DB is that whole pool thing that I talked about. You have cases definitely where you're sharing DB, but you have to enforce the isolation at the column level where you're introducing the tenant ID column to ensure that one tenant does not have access to another tenant's data. So there is, I did not say that you cannot have a case of shared DB. You definitely can. It's even usually the go-to, but it's either you're sharing the DB or sharing the tables or whatever, or you are separating that at the schema level. You have separate schemas serving separate tenants. I don't know if I've been able to answer your question.
Yeah. Thank you.
All right, any other question?
Ebube, you have a question?
Yes, I do.
Okay, you can go ahead. Thank you.
All right, thank you, Ms. Gloria. Thank you once more, Mr. Erickson. You already answered, like, I had two questions, but you just answered one. I wanted to ask which one was more common in multi-tenant systems. But I was more common to use one shared database or to do sharding. But you already answered that, saying that having a shared database is more common. So my question is, because this is the first time, like, seeing, I've heard about PG also before, but like this is the first time that I'm listening on what the main use case is for it. So if you now have, in a case where you have like sharding now, would you then have like PG bouncer in each of the database, or you just have one centralized PG bouncer, or you use like a different solution, like a load balancer for the database?
Okay. You were breaking, bro. If I get your question correctly, you said in a case where you have your DB being sharded, right? Do you have a PG bouncer that sits in front of each and every one of those shards, right? Okay. Let's see. If you do the math, right? Again, it's all about optimizing the number of connections per DB. So when you have different DB nodes, right? When you have different DB nodes, you still have their individual max connections, right? So you have to sit a PG bouncer in front of that particular DB or each of those DBs for you to avoid the case where it's different from when you have one DB instance. Now you have multiple DB instances, right, with data split across board. So yes, you need to have your PG bouncer sitting in front of that particular DB to ensure that for each of those DBs. Okay, Tolu. But yeah, you have to have your PG bouncer in front of it. Yeah, Tolu, your question.
All right, thanks, Ericsson. I'm asking, I mean, for your recommendation, basically. So, my question is towards having your the tenant IDs encoded within the JWT. So, if you're having, I mean, so what would you recommend? So you have a system where you have a list of tenant IDs. So say tenant ID ABC, and then you have maybe country code. So there's a relationship between the two tenant IDs, right? So, and then you have an admin user, and then you have a user, just maybe a customer, who is supposed to have access to a particular tenant or data set. So, would you recommend that for an admin user, it is okay to have the set of tenant IDs that's list of tenant IDs mapped to the JWT token, the claim, and then as well as the country codes. Whereas just for the user, you have just one tenant ID for each of the users. So why I'm asking that question is, I mean, I'm present. I don't know this student. I'm presently within the process of building something like this. So I just want to pick your brain as regards what you recommend in this kind of situation.
Okay, I'm not really sure I get your question, but you said, do you that are you enforcing your isolation layer, or can you isolate your the data by tenant ID and country code and whatnot? Is that what you're asking?
So that's at database level. So I'm talking about having your tenant IDs in the JWT token.
Okay.
You understand? So you know JWT the claim carries. Okay, so a user has decoded the token, and then you can see the claims, and you can see that okay, this is the list of tenant IDs that this user has access to. right?
Okay, you're talking
So
about at the admin level.
yeah, at the admin level,
All right.
both user and admin, they both have when they log in, the token is assigned to them, right?
Okay.
And on their token, they both have the claims that carries the tenant IDs, right? You get what I'm saying?
Yeah.
So what I'm saying is, from your recommendation, is it okay to have more than one tenant IDs mapped to a particular, let's say, admin user, or it's not recommended that it's okay to just have one tenant ID per user, either you're an admin or you're a normal user? What do you think?
So usually at the admin level,
Yeah.
right? At the admin level, you'd probably have the authorization middleware would handle everything for the admin. So that bypass is not really the issue. Now, for users, it's probably just best to have separate is it privacy or whatever. But I get your point. For instance, now I want to be able to say click a button and then I can toggle to another
Data set,
company
yes.
or data this thing. Yeah, I understand. Exactly. I have not done the addition because usually we go to, because I think I've worked on something like this, but what we did was okay, I think we probably also attached the distance to the, and we stored it in Redis. But yeah, we attached the list of the tenants that the user has an access to in the JWT, right? Now, but I have not, that's what we built was not for scale, right? We had an idea of the max or the capacity that it was supposed to handle. So I have not sat down with this question to do the trade-off on whether it would having to append all the tenants IDs to a particular JWT would affect it. Because now, if we're talking about everything we've said, both at the Hibernate level, with having to enforce the where ID equals to this and all of that, you would now have to configure that to accept multiple IDs, right? Where ID equals to this or that, right? Or where ID is in this set. So that's a lot of configuration at the application layer. So if that's something that you're willing to, or you're ready to go with, fine. But for Spring Boot's ecosystem, it's probably just best to have multiple accounts, right? For a user to just have multiple, you don't need one user's credential accessing multiple tenants. But then again, I've not really sat down with it here. I've not really sat down with it to think of how it would affect the system at scale. But this is particularly for Java. For more flexible systems, because I think where we integrated this was for, I think was it Nest.js or so, where we did something like this. It's more flexible than Java. Java has everything on ground, so you do not have to configure so much. It offers everything to you. So you having to now start reconfiguring at the repository layer or the ORMs, this thing and whatnot, will probably just be a queue. But yeah, that's probably all I can offer.
Okay, thanks.
Okay.
All right, thank you everyone for the questions and also for the answers. Thank you for joining us tonight. Please, can we appreciate Ericsson so we can invite him next time with our favorite emojis? Please, if you say admit, oh my God. All right, thank you so much. So before we call it a night, I want to use this medium to appreciate IntelliJ, JetBrains, for always supporting us for our sections. We're supposed to have giveaway today, but then we'll move it to the next future sections. So thank you so much, Raphael, Thank you everyone for joining. We look forward to see you in our next section, same time next week. Like I mentioned earlier, I apologize for exceeding the time limit. Maybe we can move these lightning sections to 2 hours, but we have to conclude on that, yeah. But we are so sorry for exceeding our time frame. Thank you so much, and we'll call it a night here. Thank you, everyone. Thanks for joining. And do have a lovely night. Silas, the speaker is no longer on the call. All right, good night.
Oh, I've joined back.
Oh,
Sorry,
Silas,
my
are you still
network.
there?
My network.
It was a mistake. Sorry.
Okay, it was a mistake. All right, that's fine. All right, thank you, everyone. Thank you, and do have
All
a
right,
wonderful
thank you.
night. Yeah, thank you.
Thank you, everyone.
Yeah, thank you.